16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
Others have made the attempt to produce flying cars but failed. For them, sky's the limit, but not with Toyota, which is set to release a promising car. This time not on land, but in the air. You heard it right. Toyota has been cooking something never seen and driven before, possibly leaving each carmaker literally on the ground as the new product is about to soar high. It's time to reveal Toyota's plan ahead, so buckle up even tighter. It will be an exciting takeoff of automotive revelations that will destroy the industry. The impossible made possible. 1,000 years ago, our ancestors would not believe a simple something running in front of them speeding to destinations. They only knew donkeys and horses and animals possible for transportation. Fast forward to the 1800s when the first vehicle has ever been made and created. And then the airplanes were created, but the thought of flying cars, smaller ones, are not so much considered yet because of several factors preventing it. For certain, the evolution of the flying car idea has originated back in time. Let's take a trip back to the early days when the concept of flying cars was merely a spark igniting the imaginations of visionary inventors. The first prototypes emerged in the early 1900s, constrained by the technological limitations of the era. In 1917, the Curtiss autoplane made its debut, crafted by Glenn Curtiss, a trailblazer in American aviation. This pioneering prototype boasted a unique three-wing design, an aluminum frame, and a four-bladed propeller positioned behind the passenger area. It was truly an early attempt at winging it. Unfortunately, the autoplane never advanced beyond its initial test flights, leading to the project's eventual discontinuation. Fast forward to 1947, when the Convair car entered the scene. This innovative vehicle could seamlessly switch from a car to an aircraft by adding wings and a tail. It looked like something straight out of a science fiction film. Equipped with a pusher propeller, the pilot could control the flying machine from the driver's seat, redefining multitasking. Although the Convair car successfully completed a flight test, the project was ultimately shelved due to steep production costs and insufficient market demand. The dream of soaring high met the harsh realities of the ground. Will history repeat itself in flying car production? In 1956, the Taylor Aerocar was introduced, capable of reaching speeds of 120 miles per hour in the air and 60 miles per hour on the road, essentially the mullet of transportation. Despite earning FAA certification, the Aerocar struggled to find a market, resulting in only 6 units being produced. In 1989, the Sky Commuter emerged as a groundbreaking prototype for a vertical takeoff and landing aircraft, crafted by Boeing engineers. This innovative vehicle boasted 3 ducted fans and an eye-catching, futuristic aesthetic. The limited success of previous flying car ventures can be linked to several challenges, including steep production costs, a lack of consumer interest, regulatory obstacles, technical difficulties, and the requirement for specialized piloting skills. However, the landscape is changing as major players like Boeing, Airbus, Uber, and Toyota are now making significant investments in this field to foster growth. This shift has been largely fueled by the promising prototypes developed by 2 well-funded startups, both backed by Toyota. The top secret that will shock the automobile industry. Toyota's collaboration with Joby Aviation has significantly propelled the flying car sector forward. Joby Aviation, an innovative American startup founded in 2009, has been dedicated to developing a groundbreaking electric air taxi. Toyota's substantial investment of $394 million has helped elevate Joby's total funding to over $700 million. So, what sets Joby Aviation's air taxi apart? The Joby eVTOL aircraft is crafted to accommodate 4 passengers and a pilot, capable of covering up to 150 miles on a single charge, powered by 6 electric motors. With a remarkable top speed of 200 miles per hour, its distinctive tilt-rotor design enables vertical takeoff and landing, making it perfectly suited for urban settings. Moreover, the Joby eVTOL is engineered to operate with minimal noise, ensuring it won't disturb the residents below. Joby Aviation's advancements have been impressive, with over 1,000 test flights already completed. In December 2020, they formed a partnership with Uber to enhance their air taxi service, and have also collaborated with the US Air Force to investigate military uses. Despite these achievements, Joby Aviation has not yet introduced its flying cars to the general public. Experts estimate that it may take another 5 to 10 years before this technology becomes widely accepted. One significant benefit of these aerial vehicles is their quiet operation, reportedly 100 times quieter than traditional aircraft during takeoff and landing. This reduction in noise pollution could transform urban living. However, city residents may prioritize safety concerns over noise, as the thought of an aircraft crash can be more alarming than road traffic incidents. What exactly happened during the test flight in late October of 2024? Did the product live up with the hype? Joby Aviation, a California-based aerospace company, has been at the forefront of electric vertical takeoff and landing (eVTOL) aircraft development. Their partnership with Toyota, a global automotive giant, has accelerated the development and testing of their innovative air taxi. This collaboration has harnessed Toyota's expertise in manufacturing, supply chain, and quality control, combined with Joby's advanced aerospace technology. The successful test flight demonstrated the vehicle's ability to take off vertically, transition to horizontal flight, and land smoothly. This capability is crucial for navigating urban environments and accessing remote areas. The aircraft's electric propulsion system offers significant advantages over traditional helicopters, including reduced noise pollution and lower operating costs. The potential applications of this technology are vast. Urban air mobility, UAM, has the potential to revolutionize transportation by reducing congestion, improving accessibility, and significantly cutting down travel time. Commuters could soar above traffic jams, and emergency services could reach remote locations more quickly. Meanwhile, in Japan, on the opposite side of the globe, Toyota has put its resources into SkyDrive, a Japanese startup dedicated to the creation of flying vehicles. Established in 2018, SkyDrive has been making headlines with its innovative single-seat electric vertical takeoff and landing vehicle, the SD-03. This aircraft boasts a modern, compact design, measuring only 13 feet in length and 6.5 feet in width. It is powered by 8 electric motors that drive 4 pairs of rotors, strategically positioned to enhance stability and control during flight. With a maximum speed of 62 miles per hour, the SD-03 is designed primarily for short urban commutes. SkyDrive has achieved notable milestones with the SD-03, including a successful manned test flight in August 2020, which demonstrated the vehicle's practical capabilities. The company has set ambitious goals, aiming to roll out a commercial air taxi service by 2023 and to make flying cars accessible for personal use by 2028. Despite Toyota's investments in both Joby Aviation and SkyDrive marking significant progress, there remains a considerable journey ahead before flying cars become a regular feature in our skies. Challenges such as regulatory frameworks, infrastructure development, and public acceptance must be tackled for this technology to truly soar. Operating a flying car would require extensive flying experience and obtaining a pilot's license, which is no small task. Additionally, we must consider existing traffic regulations. With the potential for more vehicles in the air, the risk of accidents, such as a flying car malfunctioning, becomes a serious concern. The introduction of flying cars would necessitate a completely new set of air traffic control regulations and guidelines for urban use, as current systems are not equipped to manage the increased volume of aerial traffic, particularly in crowded urban areas. To address these challenges, Toyota is also looking to establish a network of eVTOL facilities for the landing of these vehicles. With that in mind, there are several important points to consider. While it's easy to dismiss these flying cars as whimsical or overly ambitious, the idea of a flying vehicle is undeniably exciting. However, Toyota needs to proceed with caution and carefully assess the feasibility of their plans. Joby asserts that their aircraft can reach speeds of 200 miles per hour and cover a distance of 150 miles, but such performance seems unrealistic given current battery technology. Additionally, The construction of billion-dollar eVTOL hubs in urban areas is a massive undertaking that will likely require several years to complete. Our estimate is at least 5 years. Pessimistic brands and other companies think Toyota's move will be a drastic failure as the vision remains unsustainable even in the near future years. Keep watching to discover whether Toyota and Joby pushes through this ambitious plan. A billion-dollar bet. Yes, the burgeoning world of electric vertical takeoff and landing vehicles, commonly known as flying cars, has captured the imagination of innovators and investors alike. At the forefront of this revolution are Toyota Motor Corporation and Joby Aviation, two industry giants collaborating to reshape urban transportation. Toyota's strategic investment in Joby Aviation underscores the automaker's commitment to future mobility solutions. The Japanese conglomerate has poured substantial funds into the project, recognizing the immense potential of air taxis to revolutionize urban transportation. While exact figures are not publicly disclosed, it's evident that this partnership involves a multi-billion-dollar commitment. Let's take a sneak peek of the breakdown of costs. A substantial portion of the budget is allocated to research and development, including aerodynamics, propulsion systems, avionics, and autonomous flight technology. The production of eVTOL vehicles involves advanced manufacturing techniques and high-quality materials, which can be costly. Building vertiports, or vertical takeoff and landing ports, is essential for the operation of flying cars. This requires significant investment in land acquisition, construction, and maintenance. Adhering to stringent safety regulations and obtaining necessary certifications can be a time-consuming and expensive process. Developing high-capacity, long-lasting batteries is crucial for the performance and range of flying cars. This involves substantial research and investment in battery technology. Is sky still being the limit, pros and cons of flying cars? The concept of flying cars has long been a staple of science fiction, captivating imaginations with visions of futuristic transportation. While this dream once seemed distant and improbable, recent technological advancements have brought us closer than ever to realizing this vision. The allure of flying cars is undeniable. Imagine soaring above traffic congestion, bypassing gridlock, and reaching your destination swiftly and efficiently. The potential benefits are vast. By alleviating ground traffic, flying cars could significantly reduce congestion in urban areas. Flying cars could provide access to remote areas, especially in regions with limited infrastructure. Emergency services could utilize flying cars to reach accident sites or disaster zones more rapidly. Electric-powered flying cars could contribute to a more sustainable future by reducing reliance on fossil fuels. While the potential benefits are significant, there are significant technological challenges to overcome. The development of advanced battery technology is crucial to ensure sufficient flight range and power. Integrating flying cars into existing air traffic control systems requires sophisticated technology and regulations. The noise generated by flying cars could be a concern, especially in densely populated urban areas. Rigorous safety standards must be established to ensure the safety of passengers and pedestrians. The development of dedicated infrastructure, such as vertiports, is essential for the operation of flying cars. While the full realization of flying cars may still be years away, the future looks promising. As technology continues to advance and regulatory frameworks are established, we may soon witness a new era of transportation, where the sky is no longer the limit. Toyota's vision for the future of mobility extends beyond traditional automobiles. The company aims to create a seamless and sustainable transportation ecosystem that includes various modes of transport, from ground vehicles to aerial vehicles. Electric flying cars are a crucial component of this vision, offering the potential to alleviate traffic congestion, reduce pollution, and improve accessibility to remote areas. By investing in cutting-edge technologies and collaborating with innovative partners, Toyota is positioning itself as a leader in the emerging field of urban air mobility. The company's commitment to mass production and commercialization of electric flying cars signifies a bold step towards a future where personal air travel becomes a reality. The societal and economic complications of flying cars. The concept of personal air transportation, often visualized as flying cars, has long captivated the human imagination. As technological advancements continue to push the boundaries of possibility, the once futuristic dream of soaring through the skies is inching closer to reality. However, the widespread adoption of flying cars will undoubtedly have profound societal and economic implications. The integration of flying cars into urban environments could fundamentally alter cityscapes. The need for expansive road networks and parking infrastructure may diminish, allowing for more green spaces and pedestrian-friendly zones. Flying cars could significantly improve accessibility to remote areas, especially in regions with limited transportation infrastructure. This could have a positive impact on economic development, tourism, and healthcare. As the skies become more congested with personal air vehicles, concerns about privacy and surveillance may arise. Regulations will be needed to balance the benefits of flying cars with individual privacy rights. The noise generated by flying cars could potentially impact quality of life in urban areas. Strict noise regulations and advanced noise reduction technologies will be crucial to mitigate this issue. While flying cars promise to reduce ground traffic accidents, they also introduce new safety challenges. Mid-air collisions, technical malfunctions, and the complexities of managing three-dimensional traffic patterns require robust regulatory frameworks and advanced technology for collision avoidance. Ensuring safety will be a critical societal concern. Flying cars could exacerbate existing social inequalities. Initially, the high cost of development and production is likely to make these vehicles accessible only to the wealthy, creating a divide between those who can afford advanced mobility and those who cannot. Policymakers must consider strategies to make flying cars more inclusive, such as subsidies or shared ownership models. Flying cars could revolutionize lifestyle patterns, enabling people to live farther from urban centers without sacrificing convenience. This could lead to the expansion of suburban and rural areas, potentially reducing housing pressures in cities. However, it might also contribute to urban sprawl and environmental degradation if not managed carefully. The widespread adoption of flying cars could disrupt traditional transportation industries, such as automotive manufacturing and public transportation. New job opportunities may emerge in sectors like air traffic control, maintenance and manufacturing of flying cars. The development of vertiports, or vertical takeoff and landing ports, will require significant infrastructure investment. This could stimulate economic growth and create new business opportunities. The value of real estate may be influenced by the accessibility and proximity to vertiports. Properties located near these facilities could become more desirable and valuable. The increased energy demand associated with flying cars could have environmental implications. The development of efficient electric propulsion systems will be crucial to minimize the carbon footprint of this new mode of transportation. Flying cars, particularly those powered by electricity, could contribute to reducing greenhouse gas emissions if they replace fossil fuel-based transportation. However, their environmental impact will depend on the source of electricity used and the efficiency of their designs. Conversely, increased use of airspace could contribute to noise pollution and impact wildlife, requiring careful environmental assessments and regulations. The societal and economic implications of flying cars are far-reaching and complex. While the potential benefits are significant, careful planning and regulation will be essential to mitigate potential negative impacts. As technology continues to advance and societal attitudes evolve, the future of transportation may well involve personal air travel. Do you share the same societal perspective on the idea of flying cars? Toyota is not alone in the race. While Toyota and Joby Aviation have made significant strides in the development of flying cars, they are not alone in this groundbreaking endeavor. Several other companies worldwide are actively working on their own eVTOL vehicles. Known for its sleek, all-electric jet design, Lilium aims to revolutionize regional air travel. Their eVTOL aircraft can take off and land vertically, then transition to high-speed horizontal flight. A German company focused on urban air mobility, Volocopter has been conducting successful test flights of its multi-rotor eVTOL aircraft. Their vision is to create a network of air taxi services in major cities. An American company backed by Stellantis, Archer is developing a high-speed eVTOL aircraft designed for passenger transportation. Their aircraft is designed for short-haul flights, primarily within urban areas. A subsidiary of Chinese electric vehicle maker Xpeng, Aerot is working on developing flying cars. They are focusing on both passenger and cargo transportation. These companies, along with many others, are racing to bring the dream of flying cars to reality. The potential benefits of this technology are immense: reduced traffic congestion, faster travel times, and increased accessibility to remote areas. However, significant challenges remain, including regulatory hurdles, infrastructure development, and public acceptance. As the technology matures and regulatory frameworks are established, we may witness a future where flying cars become a common sight in our skies. This new era of urban air mobility could redefine the way we travel and live. Do we still need flying cars? As everyone else knows, small helicopters exist, even two-seater helicopters. The existence of small helicopters does not negate the need for flying cars. Instead, the two serve different purposes and target different user groups. Small helicopters are effective for niche applications, such as medical emergencies, law enforcement, and executive transport, but they are not practical for mass adoption. Flying cars, with their focus on accessibility, sustainability, and urban integration, offer a unique solution to modern transportation challenges. They bridge the gap between traditional ground vehicles and aerial transport, making them a crucial innovation in the future of mobility. There are key differences between the two flying vehicles. Flying cars are designed to operate like traditional cars, with the added ability to transition to aerial travel. This dual functionality makes them more intuitive for users accustomed to driving, compared to small helicopters, which require specialized pilot training and licensing. Flying cars aim to integrate seamlessly into everyday life, potentially being operated by average consumers using automated or semi-automated systems. Small helicopters, on the other hand, are limited to a niche group of trained pilots and are generally impractical for widespread personal use. Flying cars are envisioned to use urban-friendly infrastructure, such as vertical takeoff and landing, VTOL pads and charging stations, often integrated into existing urban layouts. In contrast, small helicopters require larger helipads or open spaces, making them less adaptable to dense urban environments. Moreover, flying cars may eventually integrate with current traffic systems, transitioning seamlessly between roads and airspace. This versatility addresses the last-mile problem that helicopters cannot solve, as helicopters rely solely on air travel. Small helicopters generate significant noise pollution, making them unsuitable for widespread urban deployment. In contrast, flying cars, especially electric models, are being designed with quieter propulsion systems, minimizing noise impact in residential and urban areas. Additionally, many flying car prototypes are being developed with sustainability in mind, utilizing electric or hybrid power sources to reduce greenhouse gas emissions. While small helicopters can also adopt these technologies, their designs are less efficient for energy use compared to flying cars optimized for urban air mobility. Flying cars are projected to be more affordable than small helicopters due to advances in manufacturing technologies and economies of scale. Small helicopters, often handcrafted and maintenance-intensive, remain prohibitively expensive for most consumers. Flying cars, once mass-produced, could democratize aerial mobility, offering a viable alternative to conventional ground transportation for a broader audience. Flying cars are being developed with advanced safety features, such as automated navigation systems, collision avoidance technology, and vertical takeoff and landing capabilities. These innovations are designed to reduce human error and enhance operational safety. In contrast, small helicopters rely heavily on pilot skill and manual operation, which increases the risk of accidents, particularly in adverse weather conditions or urban environments. Flying cars are uniquely positioned to address urban mobility challenges. Their ability to transition between road and air travel makes them ideal for congested cities where small helicopters are impractical due to space and noise constraints. flying cars can operate within existing urban frameworks, offering a scalable solution to traffic congestion. While flying cars present compelling advantages, their development is not without challenges. High development costs, regulatory hurdles, and the need for significant infrastructure investment remain barriers to widespread adoption. Similarly, small helicopters face limitations in terms of accessibility, noise, and operational costs. The key question is whether the advantages of flying cars outweigh these challenges, particularly in comparison to small helicopters. As technology evolves and regulatory frameworks adapt, flying cars may become a more viable and practical solution for personal aerial mobility. While small helicopters provide valuable aerial mobility, they cannot fully address the demands of modern transportation in terms of accessibility, cost, safety, and environmental impact. Flying cars, with their versatility and potential for mass adoption, represent a transformative solution that complements and surpasses the capabilities of small helicopters. As technology and infrastructure evolve, flying cars could become an essential part of a sustainable and efficient transportation ecosystem, paving the way for a new era in personal mobility. Differing perceptions on flying cars. The perception of flying cars varies significantly across different societies, shaped by cultural, economic, and technological factors. Understanding these diverse perspectives provides valuable insights into the global implications of this groundbreaking innovation. This essay explores how various societies perceive flying cars, highlighting differences in enthusiasm, skepticism, and readiness for this futuristic mode of transportation. In Western nations, such as the United States and parts of Europe, flying cars are often seen as the pinnacle of technological advancement and personal freedom. Rooted in the futuristic ideals popularized by science fiction, these societies associate flying cars with progress, convenience, and the potential to overcome traffic congestion. Enthusiasm is further fueled by a strong culture of innovation, venture capital, and entrepreneurial spirit, which supports startups and companies working on flying car technologies. Asian countries, particularly Japan, South Korea, and China, exhibit significant interest in flying cars, often viewing them as a solution to urban congestion and limited space. These societies are quick adopters of new technologies, driven by government initiatives and public fascination with cutting-edge advancements. For instance, Japan and South Korea have outlined ambitious plans for air mobility infrastructure, reflecting both societal acceptance and readiness. In many developing countries, the perception of flying cars is tempered by practical considerations. While the idea is intriguing, it often seems disconnected from immediate needs, such as improving basic infrastructure, access to education, and healthcare. For example, in parts of Africa and South Asia, where road networks and public transit systems are still underdeveloped, flying cars may be viewed as a luxury accessible only to the wealthy elite. Concerns about cost, safety, and regulatory challenges contribute to skepticism. Without the necessary economic and technological foundation, flying cars can appear as an impractical aspiration rather than a viable transportation solution. In environmentally conscious societies like those in Scandinavia, flying cars are viewed through the lens of sustainability. There is cautious optimism about their potential to reduce greenhouse gas emissions if powered by renewable energy. However, these societies also emphasize the need for rigorous environmental assessments to ensure that the benefits outweigh potential drawbacks, such as noise pollution and disruption to wildlife. In island nations like Singapore or the Maldives, flying cars are perceived as a practical solution to geographic challenges. The ability to connect remote islands or avoid overburdened ferry systems positions flying cars as a desirable innovation. However, environmental concerns about their impact on fragile ecosystems temper this enthusiasm. In affluent societies, flying cars are often seen as a status symbol, representing wealth and exclusivity. Early adopters in these societies are likely to include high-net-worth individuals, further reinforcing the perception of flying cars as a luxury item. However, government and private sector efforts to democratize access through shared mobility models could broaden their appeal. In emerging economies, the perception of flying cars is heavily influenced by their potential to disrupt existing industries and create new opportunities. These societies may view flying cars as a pathway to economic growth, particularly through job creation in manufacturing, maintenance, and air traffic management. However, the high initial costs may delay widespread adoption. In societies with stark income inequality, flying cars may be perceived as a symbol of further social division. The high cost of ownership could create a mobility gap between the wealthy elite and the general population, exacerbating existing inequalities. Conversely, in societies with a strong emphasis on social equity, such as New Zealand, discussions about flying cars often include considerations of affordability and accessibility. In some societies, flying cars evoke deeper cultural and religious symbolism. For instance, in parts of the Middle East, flying cars align with the vision of a future rooted in technological leadership and prosperity. In other regions, traditional values may prompt skepticism about the need for such innovations, emphasizing the importance of addressing societal challenges before pursuing futuristic technologies. Toyota is geared to fulfilling the dream. As one of the world's largest automakers, Toyota has a reputation for pioneering advancements in automotive technology. From hybrid vehicles like the Prius to hydrogen-powered cars such as the Mirai, the company has consistently sought to lead the industry. Developing flying cars is a natural extension of this legacy, allowing Toyota to position itself at the forefront of a rapidly evolving transportation landscape. Flying cars represent the next frontier in mobility, combining automotive and aerospace engineering. By investing in this innovation, Toyota aims to demonstrate its expertise across multiple domains, solidifying its status as a technological trailblazer. Toyota recognizes the immense market potential of flying cars. The global urban air mobility (UAM) market is projected to grow significantly in the coming decades, offering lucrative opportunities for companies that enter the space early. By establishing a presence in this emerging industry, Toyota can diversify its portfolio and tap into a new revenue stream. Furthermore, flying cars could open up new business models, such as ride-sharing services and on-demand aerial transport. Toyota's partnership with companies like Joby Aviation underscores its interest in combining vehicle manufacturing with innovative service platforms, broadening its influence in the mobility sector. Toyota's push for flying cars reflects its broader vision of mobility as a service, a MaaS. The company envisions a future where transportation is not limited to roads, but extends into the skies, creating a seamless, multimodal mobility ecosystem. This vision aligns with Toyota's overarching goal of becoming a mobility company rather than simply an automaker. By investing in flying cars, Toyota is preparing for a future where transportation is more integrated, autonomous, and customer-focused. This forward-looking strategy ensures that the company remains competitive and relevant in an industry undergoing rapid transformation. Flying cars sit at the intersection of automotive and aerospace technology, offering an opportunity for Toyota to expand its expertise into new territories. This integration requires advances in lightweight materials, battery efficiency, and automated navigation, fields where Toyota already excels. By applying its existing knowledge to the development of flying cars, the company can drive innovation and gain a competitive edge. Toyota's commitment to flying cars also serves to enhance its global prestige. Entering the flying car market positions the company as a visionary leader, capable of tackling ambitious projects that redefine the future of transportation. This prestige not only boosts Toyota's brand image, but also attracts top talent, investors, and partnerships essential for long-term success. Do you agree that flying cars are the future? Let's hear your thoughts in the section below. See you in the next video.